All right, this is our first video for our first unit. This is the measurements unit. Now, before we start to get into the material for this unit, just want to set some expectations. While you are watching the videos, you can always feel free to pause them or to rewind them if I go through anything too quickly. You should be following along in your note packets. Make sure that you're writing down important information, and obviously make sure that you are doing the example problems as we do them together. All right, so measurements make observations more meaningful. So we can't just say, like, something's large. Like, what's it large in relation to? Is it, 2,000 kilograms? Or is it 100 kilograms? So when you have units on there, it makes your observations much more meaningful. A lot of this unit, we're going to be talking about some of the lab skills that we'll be doing and some of the fundamentals that we will need for our calculation. All right, first thing is mass and weight. So obviously mass and weight are related, but they are not totally the same thing. So mass is going to be measured in grams or kilograms, depending on the size. And mass is independent of gravity. Weight is dependent upon gravity. So next year when you take physics, you'll learn that weight is equal to mass times gravity. So that's why, on the moon, an astronaut would be weightless, but they still have mass. They still have the same amount of mass. So mass is actually the preferred thing that we'll be using in science because it's more consistent. Now, even if you're not going to the moon, gravity does change slightly based upon the elevation. So the force of gravity can change if you are way above sea level, like Denver, or way below sea level. So mass is a more consistent measurement. So we just want to get in the habit of, like in lab, saying that we are taking the mass of something. We are not weighing it because we are going to be measuring it in grams or kilograms, and weight would be pounds or ounces. All right, so temperature, just like weight and mass are not the same thing, heat and temperature are not the exact same thing. Clearly, they are related to each other, but heat is a type of energy. So it can be gained, it can be lost, it can be transferred from one object to another. Heat is going to be measured in joules or kilojoules, depending on the size of heat that is transferred. Temperature, on the other hand, is a measurement of the average kinetic energy of the molecules. And kinetic energy is energy of motion. So as you heat up a sample of something, what happens is those little molecules inside of it start to move faster and faster and faster, gaining kinetic energy, which registers a higher temperature. So temperature has to do with the speed of the particles, and heat is an actual type of energy that can be gained or lost. So they're not exactly the same thing, but obviously they are related to each other. And then one final thing on here, heat flows from hot to cold. So when you walk outside in the winter, the reason why you get cold is because heat leaves your body, and then your body is colder due to the lack of heat. So you can't gain cold, you can only lose heat, which then makes you feel cold. All right, in this animation here, we are going to look a little bit more at molecular motion and how that changes with an increase in temperature. So right now we have neon gas in the solid phase. So sorry, not neon gas, because right now it would be a solid because we are at a very, very, very low temperature. So the particles are still moving, even though they are in the solid phase. We know that this is a solid because they are very close together and they are lined up neat and orderly. As we heat our sample up, you can see that the temperature is increasing and the particles start to move more. So as heat is applied, the kinetic energy of the particles increases. As the kinetic energy increases, you'll see the particles moving around more. And now they would be entering, some of them are entering the gas phase, moving around the container. So the higher the temperature, the greater the kinetic energy. So the molecules will be moving around more. If we cool our particles back down, then you will start to see their molecular motion slow it down. So this is going to be a big idea throughout the year. As you add heat, you are speeding up those little individual molecules. And once they are at a higher temperature, then they will have more kinetic energy. And we can see this with different things. Like we could take water in the solid phase. They're still moving. They still have kinetic energy, but they are not free flowing like they would be in a liquid. So we have a higher temperature. Now we're at 286 Kelvin. When we are at 430 Kelvin, it would be the gas phase and the molecules have a much higher kinetic energy. All right, we're going to see questions like this very frequently throughout the year. So in which sample do we have the highest average kinetic energy? Now, a lot of times you'll see this with the word average in there, because as you saw in that animation, not every single particle is moving at the exact same speed. So that's why they say average kinetic energy. So highest average kinetic energy, only thing that we care about is temperature. So highest kinetic energy means particles moving the fastest. So you just want to pick whichever one has the highest temperature. So the highest temperature would be 35 degrees Celsius. So that would be our answer. Now in that animation, you should have noticed that the temperatures were reported in Kelvin. So we are going to use Celsius and Kelvin in chemistry. Occasionally we'll talk about Fahrenheit because that's the temperature that we tend to be most familiar with. So I might say like this would be equivalent to approximately this temperature in Fahrenheit, but all of our measurements are going to be in Celsius and all of our calculations will be either in Celsius or in Kelvin. Now, on the very back of your reference table, so if we flip to the back page of our reference table, the last formula given on there is a conversion between Celsius and Kelvin. It's a very easy conversion. So if you have Celsius, you add 273 in order to get the corresponding Kelvin temperature. And then if you had Kelvin, you would subtract 273 to get the Celsius temperature. So for question number 1, we have our Celsius temperature, 25 degrees Celsius. And in order to get to the corresponding Kelvin temperature, you would just add 273. So that gives us 298 Kelvin. And that is just a touch warmer than room temperature. All right, number 2, we have our Kelvin temperature. So we would subtract 273 to get the corresponding Celsius temperature. So 352 minus 273 would give us 79 degrees Celsius. Now notice for Kelvin, we don't use the little degree symbol and we do for Celsius. That's just, a slight difference in notation. Number 3, negative 15 degrees Celsius. So we have our Celsius. So then we just add to 73 to get the corresponding Celsius, or sorry, the corresponding Kelvin. Celsius can be negative, but Kelvin never will be negative. So this will give us 258 Kelvin. Now, some important points that we need to know. So freezing point for water, assuming that we're at standard pressure, is 0 degrees Celsius, which would be equal to 273. That is also equal to 32 degrees Fahrenheit. We're pretty good about remembering that because we know that water can freeze, ice can form, it can snow at 32 degrees Fahrenheit, which is the same thing as 0 degrees Celsius. Boiling point for water in Fahrenheit is 212 degrees. That is 100 degrees Celsius. So the Celsius scale is set up based upon water. So 0 is freezing point for water, and 100 degrees Celsius is the boiling point. And that would correlate with 373 Kelvin. Now we have this other thing called absolute zero. Absolute zero is 0 Kelvin. So I said on the previous slide that your Kelvin temperature can never be negative. Temperature goes along with kinetic energy. Higher temperature, greater kinetic energy means molecules are moving faster. Lower temperature, less kinetic energy, meaning the molecules are moving slower. So if we have no temperature, we would have no movement. That theoretically happens at 0 Kelvin. Theoretically, because no one has reached 0 Kelvin, but they have gone down into the single digits, and it is well thought that if you get to 0 Kelvin, there would be no kinetic energy and no movement whatsoever of the molecule. All right, a lot of times in lab, we will be measuring volume. Typically, we will be using a graduated cylinder to measure volume, and we will be measuring volume in milliliters. Most frequently, if we had a larger amount, we could be measuring that in liters. If we were working with a solid object, so these would be used for a liquid. If we were working with a solid object, we might be doing length times width times height and getting a volume in either cubic centimeters or cubic meters if it's very large. And a cubic centimeter is equivalent to a milliliter. So we may have to convert between those when we are doing density problems. All right, so right now you might be thinking, what do moles have to do with chemistry? Moles is going to be something that we are going to spend a lot of time this year talking about. We are going to do an entire unit talking about how a mole is useful in chemistry and what the heck it means. Right now, what you need to know is that moles are used to measure the amount of something. So, for example, we all know that 1 dozen equals 12. And it doesn't matter what we're measuring. If we have a dozen donuts, we know that that's 12 donuts. If you have a dozen flowers, that means that you have 12 flowers. If you have a dozen people, that means you have 12 people. Moles is the same idea. 1 mole of something, anything, means that you have 6.02 times 10 to the 23rd of them. So if we have a mole of water molecules, that is 6.02 times 10 to the 23rd water molecules. If you have a mole of oxygen gas, that means you have 6.02 times 10 to the 23rd molecules of oxygen gas. So like I said, we're going to do an entire unit on moles in a little bit. What you need to know right now is moles are used to measure the amount of something. And if you can start memorizing that number, 6.02 times 10 to the 23rd, that would be great.